So it's about dilutions and solution stoichiometry. So the front of the sheet is mostly about dilutions. So dilutions uses a very straightforward and simple equation that we call m1v1 equals m2v2. So if I look at the first problem, basically I'm saying the first molarity times the first volume equals the second molarity times the second volume. So when you dilute something, you're adding more liquid, let's say, more water. So these are grouped together, right? You're saying you diluted 10 milliliters of this 6 molar sulfuric acid. So basically, I could call this a 1 or a 2. So if I call that 1, I have to call this 1. If I call that 2, I call this 2. And now I'm going to make 250 milliliters. So I went from 10 mils to 250. So it's that much more liquid. So I'm diluting it. So that is definitely not a M, that is a V. So that is volume 2. And then it's saying, what is the concentration? Concentration is always M. So that's going to be the new molarity. So now I just group these together. So I say the 6 molar M1 times V1 equals M2, don't know that, times V2. And the important part of this is that you make sure that those units are the same. All right, and if I calculate that out, then I'm going to get well, let me show it to you. So 6 times 10, which is 60, divided by 250 is 0.24 molar. Should make sense that my concentration went down because I'm diluting it, okay? So all these are like that, but I want to talk about number 6. So it says, how much water would I need to add to 400 milliliters of a 2.4 molar KCl solution to make 1 molar? So I'm diluting it, right? It went down. So I'm going to call this 1. This is V1. This is M1. This clearly is M2. So it's how much is probably liters. So it's an important ending to this problem. So I have 2.4 molar times my 400 milliliters, okay, equals 1 molar times my V2. So when you calculate this all out, you're going to get 960 milliliters. That's what the new solution will be. But here's the key. It's how much do I need to add? I already had 400 milliliters. So instead of saying what's the new volume is this. Great. That's great. But this one was asking how much more do I have to add? So I'm going to add 560 milliliters of H2O added, okay? So that is how you do M1V1 equals M2V2. Okay, a little different shift. Solution stoichiometry. We're gonna actually go to the next page to talk about this. So I still have the stoichiometry right here, but now we're also talking about solution stoichiometry. Well, in solution stoichiometry, you have moles, and moles are right here, right? So you're going to utilize your molarity equation, and you're going to be able to go in and out with moles, okay? So let's talk about this equation for an example. It says, what mass of zinc, so I want grams, will react with 2 liters of 0.25 molar HCl. So I have 2 liters of 0.25 molar HCl. So if you're thinking about this, I'm looking for zinc. So that's what I'm looking for. So I want to go here. So where the heck do I start? If you go, oh, you have liters. Careful, that's for gases. I need to get to this. Okay, guys, think about it. If you have liters in molarity, if you have 2 of these 3, you can get the third one. So in this case, I have this to begin with. I have 0.25 molar HCl equals 2 liters over moles of HCl. So if I do that, right, you're going to multiply the 2 times the 0.25. And you can do this in a T-chart as well, but I kind of like doing it this way. I think it's more visual. You're going to get 0.5 moles of HCl. Now I'm here. Now I just need to get from here to here. So how many steps is that? 1, 2. So I set that up. So now I'm going to mole ratio already. So that's for every 2 of these, I have one of these. Then I bring the one down. And if I were going to particles, I'd use Avogadro's number, but I'm going to grams. So I'm going to write 65.4 grams of zinc. And I get roughly 16 grams of zinc. Okay? All right, let's take a look at a different problem. So if we come down to, let's say, this problem right here. It says how much, so much will probably be liters, of HCl would be needed to dissolve CaCO3 pearls that weigh 4 grams. So I have 4 grams here, and I want to know the liters of this, and I have this. What don't I have? I have liters, I want to know liters, and I have molarity. I haven't mentioned moles. So I'm going to start with grams, and I'm going to try to stop at the moles this time. So this time I'm going to do this. It's 2 steps. So this is roughly 100.1 grams. I know I'm doing HCl again, but that's okay. It's a 1 to 2, so it's a 1. Oops. 2. I'm going to calculate that out. Okay, now I need to plug that into my molarity problem. So I have 0.8 molar equals 0.0799 moles. And I want to know liters. And if I do that, I'm going to basically divide by 0.8. And it roughly becomes 0.0999 liters, which is about 1.0 liters, right? Approximately, if I round. Okay, so that's how you would do some of those problems. So either you start with a molarity or you end with a molarity problem. And you're then going to do the other half with a T-chart. So I hope that helps.